All right, this time we're going to be solving some one-step equations using the conventional algorithm. I mentioned the fact that we're going to use this algorithm because you have to write your work the way that I've been showing you in class and the way you're going to see it in this video. And I know that there's many of you that could look at these equations and figure out, oh, x minus 3 equals 4. Oh, obviously x has to be 7, right? And you're just going to write a 7 there, or x equals 7 is your answer. That's not going to be good enough. The reason for that is not only are you practicing being able to find the correct answer, we call it the solution to these equations, which you really should have got good at in 6th grade anyways. The 7th grade step up of that is learning this conventional, which just means it's the way everyone does it, this conventional way of writing it so that when you see it in your future teachers will use it, or when you see it in books, you'll know what they're doing. When people look at your math in the future, they'll know what you're doing. And it's also the absolute best way for keeping track of your work. When you start getting to harder and harder equations, not just one-step equations that can be solved in one step, where we'll do 2 steps in 7th grade, and some of those you might be able to do in your head, some of them you won't. But then you'll eventually get to equations that have so many steps and take up a whole piece of paper to do, and you won't be able to do them in your head. And if you don't know this method for writing and keeping track of your work, you won't be able to do it. And you'll be like, oh, why didn't I learn that in 7th grade? So that's why I'm forcing you to do it now. So let's go ahead and get started. The trick is to look at whatever operation is happening to your variable or whatever operation is like some other number is doing to your variable on the side of the equation that has the variable. And then you just want to do the opposite of that. And you have to write and show that that's what you're doing. But just like with fractions, when you do something to the top of the fraction, you got to do it to the bottom of the fraction to keep it equivalent as you go across. Equations are the same way. Think of them as balancing scales, those old-timey scales where, like, if you put the heavier stuff in this hand, it goes down, or if you put the heavier stuff in this hand, it goes down. It's the same idea. You need to do the same thing to both sides of that scale so that they don't get all like this. So if I see v minus 10 on this side of this equation, well, I want to counteract or undo that minus 10. We call this isolating the variable. My goal is to turn that minus 10 into a 0, cancel it out, leaving the v by itself, which we call isolating, right? Isolating is to make something by itself. But if I add 10 to this side of the equation, when I say this side of the equation, I mean this side of the equal sign. Some 7th grade teachers really like it if their 7th grade students draw a line straight down from the equal sign when they're solving equations to help them like remember, okay, I need to do a thing on this side of the equation, I need to do a thing on this side of the equation. And it also helps keep things nice straight lines. Because I need to add 10 over here on this side of the equation. And then when I write my next equation, because this right here we call a solution step, I'm just going to write step, but it's a solution step, right? That's why it's called a one-step equation. This is the one step we're going to show. After each step you do, you should have a new equation. What new equation comes from that step? Well, let's do a little bit of math and see what we got now. If you think of this minus 10 as instead of that, just think of it as negative 10. Well, when you put a negative 10 and a positive 10 together, you just get 0. So what we have left on this side of the equation is a v and a 0. But we don't really need that 0. It doesn't do anything. So we just have v left by itself, isolated. Then I'm going to bring my equal sign down right there on that line. I'm not going to write that line every time. I'm just kind of trying to show you how. Notice I didn't write the v straight down from where it was. I kind of scooted it over to the left to the right. And the reason I did that is because I know that I want the equal sign to stay straight in line. When I'm writing these, I don't want that equal sign to kind of bounce around to the left and the right, depending on how my equation's changing. I want those equal signs straight down, and I'll move the other things to make it so that the equal sign is in a straight line. Okay, so negative 9 plus 10, that's positive 1. And so now we have our isolated variable. We have our solution here, and we're good. I like it when students box it. You don't have to. I'm not requiring you to verify your solutions on this particular assignment, but you can do it real quick in your head to make sure you got it right? You can take this 1 and put it back for v in the equation and go 1 minus 10. Is that -9? It is, and that's how you know you got it right. Good idea to always do that on quizzes to make sure you're getting stuff right. All right, let's do the next one. So you know what? I actually already told you what the solution to this one is. This is a pretty easy one. You do that one. How about, I'm going to bounce down to number 4 because this one has that fraction in it, or we call a rational expression. And those tend to be a little bit tougher for students sometimes. So let's look at what this 5 is doing to our x. It's dividing, right? This says x divided by 5 equals 2. Our goal is to undo that, cancel it out, counteract it, whatever words you want to say. Whatever we see happening to our variable, we just do the exact opposite of that. But we have to do it to both sides of the equation. So the number we're looking for divided by 5 equals 2. That means if we take both sides of this equation and times it by 5, so I'm using this dot 5 to mean times 5, then I have to do the same thing to the other side of the equation, 2 times 5. And when I say other side of the equation, I mean, look, one of those is on this side of the equal sign, and the other one is on this side of the equal sign. Now, this part right here, x divided by 5 times 5, gets confusing for students sometimes. So let me show you what not to do. What I see a lot of is students will have this x divided by 5 and then times 5. And they get really tempted to do the 5 times the 5. They see a 5.5, and then they wind up with this thing here, x over 25. No, please don't do that. Nope, 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 nope. You got to think of it this way. It's like, yeah, the 5 and the 5 are close to each other, but what are you really doing? You're taking some number divided by 5, and you're timesing that by 5. Think of a number that's easy to divide by 5 and do that whole process in your head and see what happens. What if x was a number that's pretty easy to divide by 5, I would say is 10. So what if x was 10? Then you're doing 10 divided by 5, right? I'm writing this as x divided by 5 as a fraction. I'm writing it as divided by 5 with a symbol just because I feel like that's easier for people to read sometimes. And I'm just pretending that x is 10. It's not in this case, I don't think so. Okay, so that's equal to 2. But then what I'm choosing to do is times that by 5. Okay, so I'll do 2 times 5. And that gets me back to 10 where I started from. It just reverses things. It just gets me back to my starting point. And that's always your goal, is to get back to where you started from, get back to that variable, in this case x, all by itself. If you're doing anything other than that when you're solving an equation, you're probably making a mistake. So the idea here is x divided by 5, then times 5, leaves you with just x. Whatever number that was, if you divided it by 5 and then times it by 5, you should be back to whatever number that was you started with. But in order to do that, we got 2 times 5 equals 10 on the other side to keep the equation nice and fair. Oh, it does turn out to be, I didn't do that on purpose. It does turn out to be 10 in this equation. And so like we basically already did it on the other side. We already verified. If you were to take that 10, put it here for x, 10 divided by 5 is 2. So, all right, let's hear. How about we skip to, we'll go straight down. This one's got some big, ugly negative numbers in it. So let's do this one together. Let me switch colors. It says negative 13m equals negative 377. Okay, so when I've got a number right next to the variable, that means multiplication. This says negative 13 times my variable m. So I want to undo that. I want to undo this multiplication using division. I'm going to divide by negative 13m, not negative 13m, just negative 13. And now the idea here is any number divided by itself is 1, right? I've got, like thinking of this as a fraction, I've got negative 13 on the top of this fraction and a negative 13 on the bottom of the fraction. They should cancel out and make a 1 together, right? Leaving me with just 1m, which is always my goal, just having m or 1m, same thing. by itself so that the other side of the equal sign can just tell me how much that m is worth. So this becomes just m equals, well, if I divided by negative 13 on that side of the equal sign, I got to divide by negative 13 on this side of the equal sign. Now, I'm not drawing this line anymore to keep the sides of my equation like straight and even, but I'm still trying to do it. Notice my equal signs were pretty much in line when I solved this one. My equal signs are almost in line in this one. Maybe this one's a little too far to the right, but you know, they're not going everywhere. Okay, so let's see here. Negative 377 divided by 13. Well, I think I'm going to get a positive, right? Negative divided by negative is positive. So let's see here. How many times can 13 go into 377? 30 would make 390. So it's got to be 29. I'm going to go with 29. Tell me in the comments if I got that wrong. All right, and let's box it. And, you know, if you wanted to make sure whether or not you got it right or wrong, but use our verification process. Put 29 for m, do negative 13 times 29. It better come out to negative 377. If it doesn't, then somebody goofed. All right, let's see here. How about we bounce? So let's look here. We've done an equation with a minus in it. We've done an equation with a division in it. We've done an equation with a times in it. We should probably do one with a plus in it. So at least we hit all the different. Oh, I actually don't even see one with a plus in it. There's no pluses on this worksheet. Okay, well, look at what we've done. The one that had a minus, we used plus as our solution step. The one that had division, we used times as our solution step. The one that had multiplication in the equation, we used division as our solution step. So you can probably figure out, oh, if you get one that has a plus in it, use subtraction as your solution step. So whatever you see in the equation happening to your variable, you use the opposite. All right, let's do a couple more, and then I'll leave the rest for you to do. How about number 7? B minus 7 equals -1. Okay, so I've got subtraction in my equation, it's 7 being subtracted. So let me counteract that by adding 7. And then I'm going to add 7 to the other side of the equation. So this is my solution step, adding 7 to both sides of the equation. B minus 7, but then plus 7 leaves me with just B. Another way to think about it is the -7 and the +7 create a 0 together, cancel out. Bring my equal sign straight down. -1 plus 7 equals 6. All right, now as you're doing this, please be thinking about neatness and how you're writing this stuff. There is a level of expectation that you're writing this as solution step. Ooh, look, I missed a fraction bar here on this one. This should have a fraction bar above it. If you don't put the fraction bar above it, it looks like I'm subtracting 13. The fraction bar is what says I'm dividing by -13. So that was a important miss that I made right there. And so I want you to do the same thing, what I just did. Go back and look at your work, and please look at the details, because I'm going to be looking at the details of your work. Are things sort of lined up straight and neatly? Is your writing neat enough? Are your equal signs straight in line? Are you showing your solution steps and then the equations? Is it looking the way it's supposed to look? And even stuff like this. You're moving into a point in your math career where you have to write letters and numbers together a lot, right? Your B's shouldn't look too much like your 6s. I should be able to tell the difference between your B and your 6. I should be able to tell the difference between an S and a 5, although we try not to use S's because they look too much like 5s. And there's probably a few others that I could think of if I took a second to think, but I think you get the idea, right? Okay, how about, let's go down to number 12. We got -2 equals m divided by 16. All right, so our mystery number m is being divided by 16 to get -2. So if we take -2 and times it by 16, we'll get back to what m was. But we have, so you could think of it that way and just probably come up to the conclusion that the answer on this one's going to be -32. but you're learning how to show that you're doing it to both sides of the equation as you go. So I want to multiply by 16 here, and I want to multiply by 16 here. M divided by 16, but then times 16 just results in that number that we started with, which is M. Bring my equal sign straight down, nice and neat. -2 times 16 is -32. All right, and just to make my job easy so I don't have to move this paper around too much, I'll just do the one directly below. And so I will have done what? 1, 2, 3, 4, 5, 6. I will have done 6 out of 14. I think that's pretty reasonable. Hopefully you're catching the idea and you can finish the rest off on your own from there. So we got -10 equals x minus 21. Okay, so our mystery number in this case, x, has 21 being subtracted to it in order to get to -10. So if we were to take -10 and add 21 back to it, we would figure out what that number that we started from was, well, x. So the way we're going to show it, though, is by adding 21 to this side of the equation in order to cancel out or undo that -21. And we're going to add 21 to the 10 as well. Now, notice there's no equal sign here. Notice on all these ones when I showed my solution step, timesing by 16 plus 21, whatever, there's no equal signs there. That's not, I'm not making an equation there. I'm showing some math that I'm doing, my step. Below that, the next line is where I should have an equal sign because I'm going to have my x all by itself, isolated here. I'm going to have my equal sign, and -10 plus 21 is 11. So in this case, it doesn't matter that on this one, that the number is on the left side of the equal sign and the variables on the right. I think you'll do a lot more equations where it's the other way, where the letter is on the left and the numbers on the right, but it doesn't matter. You can have it both ways. All right, so in this case, 11 equals x or x equals 11. All right, go ahead and finish this off. Please make sure the way you're writing this looks like the way that I'm writing it. It's an absolute must. You can't, I know you can do some of them in your head. Doesn't matter. You're writing it is part of what you're learning and is the expectation of what you're doing in class right now. All right.